Welcome everybody to our presentation for the Dart programming language. My name is Eskander.
My name is Angel Vazquez.
My name is Mateo Lopez Moncaleano.
And my name is Benit Mukendi.
So today we are going to talk about the Dart programming language. And so first let's start with the history and background. So Dart was developed by Google on the year 2011 by Lars Bark and Casper Lund. Uh, so it was designed with the purpose of uh, having an alternative for JavaScript, and but it was not very popular at that time. Its popularity increased once it was adopted by the Flutter framework, and is now one of the most popular programming languages. So its purpose and objectives, as I said, it was to uh, have an alternative for JavaScript, and it was also designed to have a high performance, to make high performance web applications and focus on the client side, which means it was designed to be simple to use and simple also to program. Uh, it was designed to have a high learning curve for people who doesn't necessarily have a deep background in programming languages. And it was it also supports synchronous programming, which allows to the users to the programmers uh, to modify and maintain their programs, for example, in web applications without having to taking them down. Some of its unique features are it can compile to multiple targets, for example, to ARM64 for Android, JavaScript for web browsers, and x86-64 for Windows, Mac OS, and Linux. It has a just-in-time compiler, uh, which can compile your source code to machine code, and its code runs in isolates, which are chunks of memory running a single thread in an event loop, and multiple threads can also be run in parallel. So more of its unique features are that it is type safe. Its variables can be static type when specified, but by default they are dynamic, and it also provides null safety, which doesn't allow a type to be null unless specified by the programmer. Uh, and it is syntactically like combining the elements from JavaScript and Java.
So now getting into some of the major features of Dart here. Dart supports two types of type binding. It supports both static and dynamic type binding. So with static type binding, it's done by prefacing a variable that you want to declare with the desired type of that variable. So if you want to declare a variable with a integer type, you would just preface it with the type int, or if you wanted to create a string, you would preface it with the type string. And for dynamic type binding in Dart, that can be done by prefacing your variable with the dynamic keyword or the var keyword, which is short for variable. Doing this allows you to define a variable with any value that you want. It could be an integer, a string, or any of the other types supported in Dart. Static binding is determined at a variable's compile time, while dynamic binding is determined at a variable's runtime. So Dart also supports 3 types of scope binding. It supports a global scope binding, local scope binding, and class scope binding. So for global, variables can be accessed in any single part of the program. For local scope binding, variables can be accessed within the chunk of a code that it's defined in. And then for class scope binding, variables can be accessed within a class that it's defined in. Using this kind of scope binding can ensure that all the variables will only be accessible as the user desires. So for the type system, Dart has a strong static type system, which means that variable types are known at compile time and cannot be changed. This kind of type system helps with catching type errors at compile time and also with just keeping the flow of your program much smoother. So on the right over here, you can see kind of the variables that are available in Dart. So we have integer types, doubles, strings, booleans, lists, and maps. And then you can kind of see right here how they're defined. The integer value takes on just a regular integer, not a decimal. A double takes on a decimal value. The string just takes on any string of characters that you would like. The bool is true or false. Lists, you can have, essentially it's Dart's equivalent of an array. And then for maps, you would have a word mapped to a value. So right here in this map ask declaration, we have yes is mapped to 1 and no is mapped to 0. And for the type system, Dart allows several features as well, several type-related keywords, if you will. For that, we have a dynamic, which I mentioned before, is to tell the compiler to make a variable dynamic so that it's defined at runtime. You have the as keyword that's used for explicit typecasting, and then you have the is keyword, which is used just as a comparison to tell whether a variable is or not a certain type. This type system, along with its features, allow for a powerful and flexible way for coders to write and read their code. For function parameter passing, Dart supports positional parameter passing and name parameter passing. And with this, you can kind of combine the two and mix them as you'd like. So we have 2 examples here. The one on the left shows the positional parameter passing. It has a definition for int add function. We're just adding 2 numbers and returning it to the function. And so in the function call under it, you can see that you're just placing the values as you'd like in the function. You have 3 and 4. They just correspond to whatever position you put them in. And then for the example on the right, we have name parameter passing, where you're passing the value that you want into the variable that's defined in the function. So you have the void print person, and you have a string name and in age defined in there, and it's just printing a name. And when you're declaring it under there, you're specifying the variable that you want to define, and then the variable that you want to assign to that variable. For generic programming, we have kind of a similar approach as to C++, where you use templates. And the templates are used to create generic code that you can reuse with any kind of variable. So, for example, this code on the right here, we have a glass container and has a template variable t, which is encased by 2 kind of arrow brackets on the right here. So whenever you're calling this variable t, it's going to kind of assign whatever type that you want into where that variable t is. So you have class container t. Let's say if you wanted to define it with an integer type, when you're defining it in your main program, you would just do class container integer where the t is, and then it would also define the item in that class as an integer as well. Just any instance where the t is going to become that type.
We are going to talk about the Dart standard input-output system and how that is integrated into the programming language. So first, in order to even use the Dart input output system, you need to import it using the Dart IO library command. And the input output system allows the users to just manipulate and work with files, directories, clients, servers, terminals, whatnot, depending on the usage. And essentially, it implements and promotes an asynchronous API, which just practically in layman's terms means that it's just how the user and the computer communicates with one another, and doesn't have to happen at the same time. So next we can talk about the input. And so with the input for the Dart programming languages, it's in order to input anything into the terminal, into the computer, it uses the dot readline sync function. And then if you are trying to receive input to like read a certain file on your computer, it can also use the read as strings function as well. And if you look at the example, the user here use the int.parse/stdin.readline sync function, and so then it would output to console for you to read in the input, which they use the number 1. And then later on that output print statement, you see that the 1 is used in the favorite number question. And then this is similar to like other programming languages like Python, C++, and Java. And then finally, we get to the outputs part of the system, and there's only 2 ways to output to console in the Dart programming language, and that is like other programming high-level programming languages, the print statement. And then the other option that they can use as particular to Dart is the std_out.write function as well. And so as you see here, they put in the string "welcome to Geeks for Geeks" using the print statement function call. And then they use the other std.outWrite function call. And then as you can see, it outputs to for both those statements.
On to the object-oriented features of Dart. So first, let's talk about the access modifiers for class members. So class members in Dart can either be declared as public or private. So public and private class members are the same as C++ in the sense of where you can access them from. So public class members can be accessed from the main function or user-defined functions, and private class members can only be accessed or manipulated from inside the class the class itself. So they are declared differently. Well, private is declared differently than in they're both declared differently than in C++. So public members are declared just as any other variable. So for example, if I wanted to declare a age variable as a class member, I could just say int age, and that variable would just be public for the class. If I wanted to declare a private age variable, I could say something like int underscore age, and that would be private. The thing that makes it private is the underscore that precedes the variable name. So we have an example here. So looking from the top down, we see that we define a class A, and it has 2 members. So the first is they're both strings. The first member is first, and the second member is second. And the difference is that first is a public member, since it does not have a underscore preceding the variable name, and second is a private member because it has a underscore preceding the name. And then we can see some methods that are defined here. So we have a getter method on line 5. So we need a getter method for the second variable since it is private. So if we want to access or we want to get the value for that variable or that class member, we need to have a getter method which returns its value. And then on line 9, we have a setter method for the second variable. And this setter method will set the value of that variable to whatever is passed in as a parameter, since it cannot be accessed from outside the class. Moving on to the bottom picture, we have in our main function, we declare a new class object, and we call it A. And on 5 and 6, we're assigning its class members values. So for A dot first, we will assign it new first, and this will not use any setter methods. However, on line 6, we assign the second variable new second. It is using the setter method to set its value to new second. And then on line 7, when we print the values, A dot first can be accessed from here. However, A dot second uses the getter method in the class defined above to return its value. Now for inheritance. So Dart does not allow you to extend more than one class. So classes can only inherit at a max one other class. To work around this, Dart supports something called mixins. So mixins are basically they're defined as other classes with their own methods, and then they can be used together with extensions or inheriting other classes to make your class more flexible. This helps overcome limitations of inheriting over only one class, and it can it can improve class inheritance and code reusability. Now for our example, so in our main function, we declare a new duck object, and we assign it the duck class. So when we look at line 13, we have our duck class, which extends the bird class. So that's inheriting the bird's class methods, the public methods. And then it's also obtaining the mixin swimming methods from the mixin swimming. So on line 22, when we call duck.quack, that will use duck's local method quack. And then on 23, we use duck.swim. So that will use the mixin methods method. And then on line 24, we do duck.fly. So that will call the bird method that was inherited by the duck class, and it will print flying. Now for dynamic binding, so dynamic binding is enabled by default in Dart, so it is not necessary for programmers to to explicitly declare a method as dynamic for it to be known at runtime, and it will not cause errors. The behavior of methods is determined at runtime based on the type of the object assigned to the class variable. So we'll get a better idea on this next example. So let's see, in our main function, we have on lines 16 and 17, we declare an animal type object and a dog type object, and we assign them both to new animal and dog respectively. So on line 19 and 20, when we say animal or dog that makes sound, this is static, and it is known at compile time that the animal.makeSound will make the sound of the animal, so animal noise, as seen on line 4. And dog.makeSound will print the make sound that we see on line 11, which is bark for the dog class. However, when we get to line 22, this is where the dynamic binding takes place. So we assign we declare a new object type of type animal, but we assign it a new dog class type. So this will be determined at runtime. Which make sound method will be used. So on line 23, when we do dog animal dot make sound, this make sound it'll go to line 11, and it'll print bark. So it uses the dog's make sound method instead of the animal one, and that is determined at runtime instead of compile time. And that's all for our presentation. Thank you guys for watching.